electrical input. Not zero energy input, but zero external. External. When I do demonstrations we did a demonstration for the Ukrainian Institute of Thermal Physics last month. And it's why I use the term negative work versus just work. Work doesn't mean anything in this sense, but the energy it's internally created energy. It's not, and it's important to reaffirm that. Now again, what I've done, and it's in the data, and if anybody wants it, I can send you the data. The kinetic energy increase in joules equals the work performed in joules, which equals the energy required in order to perform that work in joules. So if we are increasing the kinetic energy, we're performing positive work, and we need an equivalent amount of energy from somewhere. When we're performing negative work, the same thing applies. And what I've done with both of these prototypes is I've taken them apart. I've weighed their components. I've gotten the mass of their components and the dimensions of the components. So at a specific speed, I can calculate exactly what the kinetic energy is. So if the RPM goes up, then I can calculate the increase in kinetic energy, which equals the energy, the internal electromagnetic field energy that's created. So there's no wiggle room with regards to where's the energy coming from? Well, it's being created. Okay, everybody's ready? You ready?
Ready.
dense saw. The prime mover was consuming about 560 watts at idle. So that would be your internal combustion engine going down the highway and driving the system. And then when we went into quantum motor mode or supercharger mode, with 4 coils, the consumption went down to 340.
340.
So it went down by 200 watts. Now, there's 4 coils in the system in order to allow evaluators to poke around and make sure there's nothing fishy going on, but it's designed for 12 coils. 12 coils will drive that input down not only to 0, but to a negative number. So if this is in your vehicle, depending on the size, the fuel consumption of that vehicle can be eliminated. Okay, electric vehicle. And we delivered 7 amps, right? 7 amps to the battery with acceleration.
Yes.
So we get more acceleration. So the more current that flows through the Regen X quantum motor coil or alternator coil, the difference is the alternator is connected to a battery and the motor coil is not. The more current that flows through the coil, the more acceleration is produced. The greater the kinetic energy increase. Oh, I have to go back and reduce the speed, so I have to do that. And so the more current that flows in the Regen X coil, the more acceleration is produced, the more positive work is performed. Whereas in a conventional Faraday generator, the greater the magnitude of current flow, the more negative work is performed. Okay. So what I'm going to do is I'm going to bring this back up to speed again, and I'm going to reduce it down to about 1800 RPM, half of what it should be.
Right.
And then I'm just going to repeat the process. So you can see the difference, how the frequency of operation changes the performance. The energy is the same in both cases. One is delayed in the time domain, which you saw,
Yes.
and one won't be. Okay? keep it going, it stalls.
That's right.
Okay? Alright. So that's regenerative braking. That's, again, so we are producing Faraday generator operation and Regen-X generator operation in the same coil by varying the frequency of operation, by varying the AC impedance of the coil, and what in the first scenario we're delaying the load current in the time domain, in the second one we're not. So I need your help again.
Sure.
Okay. So the electric vehicle regenerative acceleration technology is essentially the same as this. When the switches are on this side, the coils are in motor mode, okay? They're operating like normal motor coils. When they're in this side, they're in, yeah, anybody can come up and see, it's whatever. In this side, we're in regenerative acceleration mode. This could also have quantum motor mode, okay? Where we're just using the coils to purely accelerate without recharging the battery. So I'm going to bring it up to about 30 kilometers an hour. Okay. And every time I engage a coil, you're going to see, I think it's 2.5 amps per coil. Okay. And the speed of the system is going to go up. This guy cooperates. I don't think it's going to. Well, it's subtle. But we're going to repeat this, where the first test is done at 30 kilometers an hour, and then I'll drop it down to 15. So we're reducing the frequency of operation, and we go from positive work to negative work. EV regenerative acceleration, EV regenerative braking. And yeah, if you won't hear the deceleration at 30 kilometers an hour. And you can read the current here, and you'll be able to also monitor the battery voltage. The battery voltage will shoot up a little, it's going to go up a little. Now this is designed to be relatively neutral. Okay, like that's designed to show the most acceleration. This is kind of neutral because what we want from this is we want the maximum amount of current going to the batteries without deceleration. We don't really need to accelerate our AV. We just don't want deceleration. So you won't hear that.
Full charge right now in the stock batteries?
Yeah, there's 80 volts in the batteries now. Okay, you ready?
Yeah.
Just there's a bearing there, so just
Yeah, I won't touch it.
okay. And The e-bike has cruise control, so once I set it,
The states.
yeah.
Just to resume, because I couldn't really hear you.
Sorry?
Can you resume what happened?
Okay, so the first thing we did was regenerative acceleration. We brought the system up to 30 kilometers an hour. Then we engaged the regenerative coils. We delivered 7.
Tweaks and then a floor.
7.3 amps times 77 volts. We delivered 562 watts to the motor in regenerative acceleration mode. That's a 500 watt motor, by the way. In regenerative acceleration mode, and in regenerative braking, we delivered almost the same, right?
In terms of the, yes, it was the same.
This,
It was the same.
these were the same,
Yes, it was the
okay.
same.
So we reduced the speed of the system, we reduced the frequency of the coils, and then at 18 kilometers, 18 kilometers an hour, and at 18 kilometers an hour, we still maintained regenerative braking, and we deliver another 500 watts during regenerative braking. So we had regenerative acceleration above around 30 kilometers an hour, and we have 3 coils in this. Again, it's made for 12. So 560 watts times 4, that's the output, maximum output. And the more coils we engaged, the more power we delivered. Again, this is meant to be neutral. It's not meant to do the same thing as this, but all we wanted to ensure on this is that when we're in regenerative acceleration mode, we're not decelerating the EV. And it's designed to do that. And you tell me if it did that.
Yeah.
That's one.
Yeah.
Okay.
So 0 means you're not using any of the
500 and, so if we were really smart or really doing an analysis, this is a current meter that reads the current that's going from the batteries to the motor. So we'd be able to see how much current we're drawing, how much power the motor is consuming. But the gist of this is that we have the ability to exceed the motor's consumption when we have a full system. When we have 12 coils, we're generating like 4 times, right? And so the EV will be able to be charged as it drives, and ideally reach its destination with fully charged batteries. And we have regenerative acceleration mode, we have quantum motor mode, and we have regenerative braking mode. So we are using the technology and the Faraday technology 100% of the time. Is that clear? Okay, if there's questions, now is your time.
I've got a question. In normal driving
No, ask it so everybody can hear.
All right. The question I have is this: under normal driving conditions, you would never be using the full battery charge. You would never be using the charge of the battery. It would always be completely replenished. We're always generating more energy.
Okay, you have to be specific. Are you talking about in a normal EV or this?
No. In this, under normal driving conditions, that's what I mean.
Normal? Okay.
In other words, like riding on the road, using it like we would normally do any other.
Yeah. Under
motorcycle.
normal driving conditions.
Right. The battery charge would never be consumed. It would always be generating more energy than you would actually consuming.
Potentially, you can. You can exceed the motor's consumption as well.
Right.
And yes, yes to what you're saying. And what that means is you don't need 2,000 pounds of batteries in an EV.
Correct.
In order to get suitable driving range. You only need enough batteries to get you up to 30 kilometers an hour, and then you go. So in this prototype is made to have 24 coils on it. That system there was meant to go on this side, okay? So the way it would work is each coil it's called a salient pole. It's independent. So you can have, and I should have shown you on this, but you can have a Regenex quantum motor coil accelerating the system right beside a Regenex regenerative acceleration coil, right beside a regenerative braking coil. So each coil can do 4 different functions. So the coils, once it's in a full EV, the coils would be controlled by a CPU that monitors the driver input. And if the driver needs full acceleration, all the coils are just motor coils. Or maybe they're all quantum motor coils, depending on the situation. And then once the EV is up to speed, they're converted to regenerative acceleration coils, or quantum motor coils. If the battery is fully charged, they're all quantum motor coils. So you're pretty much going down the highway and you're not even using your motor. And again, your battery, you're not depleting your batteries, and your EV's not catching on fire, and you don't have to plug in, and you don't need child slave labor in Africa make the batteries, you need 100 pounds of batteries, maybe, versus a ton.
Significant.
Sorry?
It's significant for sure.
It's colossal. Yes, sir.
So much money being invested in batteries.
It's all wasted.
There's
It's all wasted. It's all, everything about,
plants being involved with Volkswagen, and
it's all wasted.
it's big, big, big business.
Yeah.
This is very disruptive. This would be a very disruptive technology.
Well, it's all obsolete. Why is it obsolete? Because lead acid batteries, which are fully recyclable, that's all you need. You don't need lithium. You don't need cobalt.